Alright, so let's look at problem 2.61 here. And this is saying a person who is properly restrained by the over-the-shoulder seatbelt has a good chance of surviving a car collision if the deceleration does not exceed 30 Gs. Assuming uniform deceleration at 30 Gs, calculate the distance over which a front end of the car must be designed to collapse if a crash is to bring the car to rest at 80 kilometers per hour. So we've got to look at a couple things. We have a uniform deceleration, so we're assuming uniform acceleration. So our kinematic equations come into play for constant acceleration. It's uniform. It's keeping the same rate of deceleration. Calculate the distance over which the front of the car must be designed to collapse if a crash brings a car to rest at 80 kilometers per hour. So it has an initial velocity of 80 kilometers per hour. To rest, we're bringing something to rest, well, that's 0 kilometers per hour. Alright, and so we have velocity, and then we have a deceleration or a negative acceleration of minus 30 Gs. And now we'll use this 1 G as 9.8 meters per second as a conversion factor in a second here. And so we need to find a distance, right here, distance. Well, of initial velocity and acceleration, we're looking at Vf squared equals Vi squared plus 2a delta x, and in this case, delta x is the distance we're looking for. So we know this is going to 0. Common thing we're seeing here. Scroll this up a bit. And so Vi squared equals negative 2AD. But let's solve for D. So this is going to become D equals Vi squared over 2A. Alright, so we have the distance that that's going to happen on this journey, but as the car crumples and stops everything down. So what we want to do is plug in our numbers, and we've got to look at some conversion factors here. So Vi is 80 kilometers per hour. But we're going to want that in meters per second. So 1 meter is 1,000. Oops, other way around. Haha, I've almost flipped it. That happens. We catch ourselves, right? So here, 1,000 meters is 1 kilometer. All right, good. There are 1 hour is 60 minutes, and 1 minute is 60 seconds squared. And so that's going to give us kilometers cancel. That'll give us meters per second. That's nice. And then down below, we're going to have 2 times. Now we can kind of get rid of our direction here. So when we brought this back over, this had a negative sign in it. And negative is going to end up hanging out with this. But the negative and the negative here will cancel. And so we can say 2 times 30 times whatever G is, which is 9.8 meters per second squared. So we have this in a format that's ready for a calculator. So let me enter this in. And so I get it so that everything's going to go in my calculator in one go. If I can find where I hid the thing here, as I got up earlier to change out my pen because of all the writing things. If you look at the video behind, and where did I set my lovely calculator? Well, we'll come over here. Let's go. I guess I'll have to use the computer calculator. So I'll put everything in my upstairs here. So I have 80 times 1,000 divided by 60 divided by 60, quantity squared divided by 2 times 30 times 9.8. And we get that this is going to crumple 0.840.